Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Muhammad Zamri. So we are from Group B. Today we will present to you about optimizing mobile phone price classification. So the overview for this project, today's summit, we are using feature selection and also feature extraction, which is filter, wrapper and PCA. Because of mobile phone price prediction is important due to the market complexity, because this is for the business. So high dimensional features lead to overfitting and reduce interpretability. So we want to know which model that we use to have the highest accuracy for this. So I will continue with the model 1. So what features we use and something like that. So first, wiper RF model 1 predict as test. We use a random forest classifier, and we want to features from our dataset and also store the as test, and then print classification report using switch alert, and then same confusion matrix, y test, y print this, which is true positive, false negative and true negative for each class. So this help to making specific error like confusing class 1 or class 2. So lastly is plotting the confusion metric. We use matplotlib as seaborn, and that's all for this is Formula 1. This is what the basic prediction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azli Fazail, 2214005. I will present about dataset and processing. So we use mobile phone dataset with 2000 samples by Jackson Devaka R from Kaggle. And then we have a target variable price range with 4 classes. That means it's from 0 to 3. 0 to 3 means the price range. So it's the class of from the lowest class of price and then to the highest. Then we have feature. We have 20 technical attributes display, which means it's very high dimensionality. And then we also pre-process with non-removable duplication checks the score normalization and certified 80/20 train test speed before training. Assalamualaikum. I'm Nazmi 2214005. I would like to continue about the with filtering and wrapping method. So first here we do filtering with the correlation matrix. Then we get with threshold 0.9, that means we get everything, a rate of everything that's above 0.9. But if you look at the correlation matrix here, there's none of the value that's actually above 0.9. So that means we don't drop any feature. If you look here, so we use every feature from a filter. So after that we go through the wrapper. So from this we get into wrapper. We use wrapper that we use exhaustive feature selector. And then it will be trained into linear regression. So for this, we actually select 4 max features. So we will train linear regression, and then we will choose the best 4 of them, and then we get the best 4 that we get is battery power, pixel height, pixel width, and RAM with a score of 95.74%. Lastly, and then we train it, and then we get, after that we predict, and then we get a very good result where we get 94% accuracy with a high precision, high recall, and high F1 score. And then this is the confusion matrix. The data set predict very well with minor misprediction in here and there, but overall it's a very good model. Thank you.
So moving on to the feature selection method. So the first one is hybrid, which is filter method plus wrapper method. So we remove features that were too similar to each other using correlation, and then we apply the wrapper method to select the 4 best features which help in determining the price of the phone. So and then the other one was PCAs. We combine features that have high correlation into 3 principal components, which together captured 85.7% of the total variation in original data. So what this means is basically we combine, of the 20 features, we combine all of them into 3 features called like PC1, PC2, PC3, which only the computer can understand, and it can capture, even though it's combined, it still captures the essence of the original So I'm going to be giving a brief overview of the PCA technique part of the code. So here we first apply the PCA to reduce the dimensionality, and then we split the dataset into training and test sets over here. So we create a data frame for the PCA components. So as you can see here, PC1, PC2, PC3, these are the combinations of each of the features, capturing the different variations of them. and then we initialize the random forest classifier to so that we can test it on, and we train the model. Then afterwards we apply the PCA transformation to the test data set to match the training set. So here, and then afterwards we evaluate it, and then we pull out the confusion matrix. So here's the classification report. As you can see here, it's 0.93%, which is pretty high. And then here's the confusion matrix. Afterwards, we give a quick comparison using graphs to capture which one is the most effective. So here, as we can see, model 1 is the hybrid, model 2 is baseline, so there's no reduction here, and model 3 is PCA, so PCA performed the best. And then here's the confusion matrix for each model. So hybrid, baseline, and PCA. So that's all for the code. So these are the results and insights. As you can see, PCA had got the highest, baseline was second, and filter and wrapper surprisingly the lowest. So PCA improved generalization, but the features are harder to interpret because they combine the features into, as I said earlier, PC1, PC2, PC3, which we as humans we can't really understand it since it's not as clear as, for example, the feature is called battery or RAM. So moving on, hybrid likely over prune, but so hybrid likely over prune means that it might have cut off too many features that were useful to determining the price, so this is why it has lower accuracy. And baseline did well, even though it didn't reduce any dimensionality or cut off any features, it still got 93%. So here's to conclude the presentation, PCA proved the best, but limited interpretability, and baseline performance was strong, so not all the time we need to actually cut off or use feature selection extraction. Context matters. And then hybrid approach underperformed, maybe because it cut off the features that are weak independent but good in combination. So the key lesson here is that we need to choose feature selection properly. We cannot just use it whenever we want, and simplification doesn't always lead to better outcomes. That's all. Thank you.